Hello everyone, welcome to our video lesson on logarithms. This is section 10.2. So far in your math lives, you've been dealing with exponentials written as an exponent. So like 2 raised to the 5th equals 32. This is an exponential form of how to write an equation. Now I'm going to teach you a logarithmic form. Okay, so here's where the basis comes from. If I want to find out what x equals, 2 raised to what power gives 10? Well, I know that 2 raised to the second power equals 4, so it's got to be higher than 2. 2 raised to the third power equals 8, okay, so it's got to be higher than 3. 2 raised to the fourth power equals 16. Okay, it has to be less than 4, so it's somewhere in between 3 and 4. So to approximate that, I could use my graphing calculator and graph it, and then I could use the trace key to see when it is approximately 10, but I'm never going to get a very exact answer. It's not the best way to solve. A much better way to solve is to use logarithms, which is what I'm going to introduce to you today. So here we have the general definition of a log form. It's another way to write an exponent. So instead of writing an exponent, we're now going to have it in log form. So the base stays in the exact same spot. It's the log base b of x equals y. Y is that exponent, which I will talk about more in just a second. It makes this statement true. b raised to the y equals x. And then we write it in this logarithmic way. It sounds kind of confusing right now. It's really not too bad. Look at this. The log base 8 of 1 equals 0. This is true if the base of 8 raised to the exponent, which is the 0 power, equals 1, true. So take a look at this now. We'll put this into more terms that you could understand. 3 squared equals 9. True statement, is it not? That's written in exponential form. Logarithmic form is log with the same base, so log base 3 of the exponent, 9, equals this exponent, 2. The log base 3 of 9 equals 2. This is the exact same way of writing this. Let's practice it again. 2 raised to the 5th equals 32. This is exponential form. To write the logarithmic form, you're going to have a log in it. It's the log with the same base. Log base 2 of the number on the right, log base 2 of 32, equals the exponent, and the exponent is 5. So that's the relationship between these two. Okay, here's exponential form, here's logarithmic form. They say the exact same thing. There's no difference between these two statements. There is no difference at all. Okay, it helps us solve. On this next slide, as you're going to learn, logarithms are the opposite of exponentials. So you can put something into exponential form and logarithmic form, and they are opposites of each other, or another way of saying it is they undo each other. They are the inverses. So just like to undo adding, you subtract. They're inverses of each other. When we're solving an equation, if it's multiplying, you got to divide. That is the inverse of that operation. If we want to square something, we take the square root of it. They're opposites of each other. So if you see exponential form, if you want to solve the equation, oftentimes you have to put it into the logarithmic form because that's how you solve. That is what the opposite of exponential form is logarithmic. Okay, let's see how we're going to use this. The first thing we're going to do here is we are going to write each of these in exponential form. So we kind of already talked about this a little bit, but let's do it again. Here we have logarithmic form. So to put into exponential form, I keep the base, 2. I raise it to the number on the right, to the negative 4, equals 1/16. So 2 raised to the negative 4th equals 1/16. And class, this will always be a true statement over here. You can put this into your calculator. What is 2 raised to the negative 4th? I guarantee you get 1/16. It's always going to make a true statement. Let's try letter B now. The base stays as the base. So here's log base 5, and we're going to have the base of our exponent be 5. 5 raised to the number on the right, 5 squared, equals 50 halves. And 50 halves is the same thing as 25, is it not? So 5 squared equals 25. It makes a true statement. So if you kind of want to think of it this way, the 5 stays there, And these two just kind of switch spots when we talk about logarithmic and exponential form. So that could be another way of looking at it. Let's try to go the other way around now. These are in exponential form. I got to put it in logarithmic. So logarithmic form has a log with the same base. So this is base 10, so we're going to keep it log base 10. And then these two basically switch spots. So log base 10 of 1,000 equals 3. I say that they kind of switch spots, and I should probably be careful when I say that because they don't exactly just switch spots. This 3 is an exponent, and it's not an exponent over here. And this 1,000 right here, don't think of this as being an exponent. It's log base 10 of 1,000 equals 3. Let's try this again for letter B. So log with the same base, log base 9 of 3 equals 1/2. Log base 9 of 3 equals 1/2. So that's how you change it from logarithmic to exponential and from exponential to logarithmic. So let's practice this a little bit more. Our directions here are to evaluate these logs. So what does it equal? What does log base 2 of 64 equal? Right now we're just going to call it x. So here's why this helps us so much is to solve this equation, I got to do the inverse. And the inverse of logarithmic form is exponential form. So to change this to exponential form, I'm going to say 2 raised to the number on the right, 2 raised to the x, equals 64. Base stays in the same spot, raised to the x power equals 64. And now I can do this by getting common bases. This was yesterday's video lesson. 2 raised to the x equals 64 is the same thing as 2 raised to the 6th power. So now I have common bases. I can set their exponents equal to each other. X equals 6. Answer. So the log base 2 of 64 equals 6. Let's try this again for letter B. What does the log base 16 of 2 equal? Well, right now it equals x. I'm stuck right now, so whenever I'm stuck, I'm going to do the inverse operation. The inverse of logarithmic form is exponential form. Let's get this thing into exponential form. 16 raised to the power on the right, raised to the x power, equals the number 2. Let's get common bases, shall we? 16 can be written as a base of 2. 16 is the same thing as 2 raised to the 4th power. That raised to the x, that equals 2 raised to the 1st power, really. So now I have base 2 and base 2. Power raised to a power I would multiply. So 4x equals this exponent. 4x equals 1. So what does x equal? X equals 1/4. And there's the answer for that. So the log base 16 of 2 equals 1/4. Why don't you guys pause the video, please, and try letter C on your own. Once again, we have to find what x equals, so we're going to change this into exponential form. 2 raised to the x power equals 1/32. So that's exponential form. Now let's solve. Let's get common bases. So we're going to have 2 raised to the x equals 1 over 2 to the 5th, because 32 is the exact same thing as 2 raised to the 5th power. Now I'm going to bring this to the numerator and just change the sign on my exponent. So 2 raised to the x equals 2 raised to the negative 5th. Now I have common bases of 2, so my exponents equal each other. X equals a negative 5. And there's the answer for problem letter C. Okay. Now what we're going to do here is we're going to solve these equations using exponentials. So log base 2 of x equals 3. What does this x equal? Right now I'm in logarithmic form, so let's change this into exponential form. Whenever we get stuck, we're going to change the form. So to put this into exponential form, the 2 stays in the same spot. It's raised to the number on the right. 2 cubed equals x. Well, now this is easy enough. What is 2 cubed? 2 cubed is 8. So x equals 8. And that is our answer for problem letter A. Letter B, I got to find what x equals. I got to change the form then. So instead of put it in logarithmic form, let's change it to exponential. 9 is still our base, so this base never changes. Okay, 9 raised to the number on the right, 9 raised to the 1/2 power, equals x. What is 9 raised to the 1/2 power? You can do that in your calculator. It's the same thing as the square root of 9, so x equals 3. There's our answer for problem letter B. Letter C, 4, right now it's in logarithmic form, so change it into exponential. 4, that's our base, raised to the 3/2 power equals x. You can do that in your calculator. What is 4 raised to the 3/2? You should get x to equal 8. Again, you can do that in your calculator. 4 raised to the 1.5 or 4 raised to the 3/2, same thing. Letter D. Now we have our base is our variable. So what does that equal? Once again, I'm going to change the form. Right now it's in logarithmic. Let's change it into exponential form. So a raised to the 2nd power equals 16. The base stays in the same spot. Raise it to the number on the right. That equals the 16. So if a squared equals 16, I'm going to square root both sides to get a all by itself. A equals both plus and minus 4. Now class, here's where we have to be a little bit careful. There's no such thing as taking the log of a negative number. So I can't take the log base negative 4. That is undefined. And so it's not going to be the negative 4. If we think about a equaling negative 4 and a equaling positive 4, this is not our answer. It's only a equals the positive 4. So cross off the negative 4. Our answer is only the positive 4. I'll talk a little bit more about that in class tomorrow. Okay, the last thing we have. If you have logarithmic form on both sides of the equation, log base b and log base b, they're on both sides of the equal sign. The log base b of x, this x equals the log base b of y, x then equals y. So if we have log base b here and log base b here, x equals y. So if we have log base 5 and log base 5, we can say that x plus 7 equals 2x. If this was log base 6, well, now we cannot do that anymore because our bases are different. But as long as our bases are the exact same, we can put what they equal to each other. Okay, so this log base 5 of x plus 7, the x plus 7, because this has a log base 5, can equal 2x. So pretty basic from here on out. X plus 7 equals 2x. So subtract an x from both sides, 7 equals x, or x equals 7. For letter B, hopefully pretty straightforward. The log base 32 and the log base 32 are the exact same log base. So that means 10x has to equal x plus 81. And now we solve. Subtract an x from both sides, and we get 9x equals 81. Divide both sides by 9, so x equals 9. There's our answer for problem letter B. And now problem letter C. Log base 5 and log base 5. If they have the exact same log base, you can set p squared minus 2 equal to p. P squared minus 2 equals p. So to solve for this now, whenever you see a squared term and a variable raised to the 1st power, or p raised to the 1st, you're most likely going to solve by factoring. So let's get a 0 on the right side by subtracting p from both sides. And now we're going to get p squared minus a p minus a 2 equals a 0. So if we're going to factor this, we're going to get p and p minus 2 positive 1. So that means p has to equal a positive 2 and p has to equal a negative 1. Now there's no such thing as having a negative base, and there's no such thing as taking the base or the log base of a negative number. So looking up here, there's no such thing as taking the log base 5 of anything negative. That cannot happen. Okay, same thing here, log base 5 of a negative number. That is undefined, and I'm going to again talk about that in class tomorrow. So this negative 1 right here is an extraneous solution. It does not work because the log base 5 of a negative 1 is impossible. So we're not going to have that one. And we should check this positive 2 as well. What is in here 2 squared minus 2. Well, 2 squared is 4. 4 minus 2 is 2. And we can take the log base 5 of 2. That's just fine. So we do have a good solution in p equals 2, but it's only p equals 2. It's not the p equals a negative 1. So to summarize, we can't have the log of a negative number, the log with a negative base. That cannot happen. Nor can you have the log base any number, log base 7, of anything negative. Both of those are extraneous. And I'll talk more about that when we get to class tomorrow. So it is a tough concept to grasp. Let me know if you have any questions when you get to class tomorrow.